to open up desmos.com. Let me change how I share the screen though. I need to share a screen in such a way that you would be able to see everything. So let me just change that up. And what I'm going to plot here is, let me remind myself, x squared versus x to the 4. So x squared versus x to the 4. Actually, do I have, is this a link that actually takes us there? It did, but I'll use it for the other one. Okay. So take a look at this. And by the way, I could have also written x to the power 6 as well. It kind of has the same kind of shape to it. So let me just get rid of that one. It's too much to look at. If I were to zoom in on this graph, let's go to home and just zoom in this way. You can see that the shape of it is kind of like a U shape, but the higher the exponent, the more flat it becomes near 0. But then after the 1, it shoots up to infinity way faster than the previous one. So let's compare the x to the 6 as well. Do you see how x to the 6, the green one, is even more flat around 0? And then it shoots up to infinity even faster than the blue one. Okay, so I want you to be aware of how does it look with one particular term. So the one that is plotted here is the f. So that's the one that's plotted already. And I'm going to, in black, I'm going to draw in green this other one just so you can see the progression. So I'm going to just try my best, crosses at 1, to do something like this. Okay, so I want you to be aware of the shape of the graph as we change to higher exponents. Let's try also with x to the power of 3 versus 5. So let's do that part. So this one, let me change to a 3. And this one, let me change to a 5. Oops, that's not a 5. And then maybe to a 7. So all the odd ones. So let's get rid of this for a moment. And let's also zoom this in. So again, it looks like a cubic saddle point, except again, it's a little bit more flat near the 0 and then shoots up to infinity after the 1 way faster than the one before it. And if I went to with 7, same idea, even more flattened at 0. And then shoots up to infinity even faster than the one previous to that one. So let's make a note. So that one's plotted in black. The green one will be the one I'm plotting. So it's going to go through the 0, more flat, and then shoot to infinity faster, more flat, through 0, and then shoot to infinity, negative infinity, much faster. So these two things would be considered polynomials, but very simple polynomials because it's only one term at a time. Okay, if you were to add more terms to the previous one, so let's keep the x to the 7. As soon as I start adding x to the power of 6 here, do you see how there's now a wobble that came back up here, plus x to the, let's say, 3. Zoom out. That didn't look like it changed anything. Let's do maybe a subtraction as well. Here we go, subtraction, because any coefficient, right? So do you see how there's many wobbles now occurring? So that's what we'll study in this unit. For now, though, simple ones will look like either like a parabola, except maybe more flat in the bottom, or like a cubic, but maybe more flat near the 0. Now, these other ones I want to also discuss with you because they're part of our power functions. These are not polynomial, because for polynomials, you're supposed to have only whole numbers as exponents, but here the exponent is like 1/2 or 1/4, right? And this exponent is like x to the 1/3. All of these, though, are called power functions. So let me use maybe a different color. And power functions is what I want to discuss next. So this is kind of like a lead-in. So all of these are all our power functions, because it has x to a particular power, and it could be any power. Okay, so let's do this comparison. What happens? So the first one that's drawn is the f at x. We're going to draw h beside it. So again, let's use Desmos. Delete, delete, delete. grab a calculator. On the calculator, I think if you go to functions, there's this nth root like this, that you can actually change the type of root it is. So we'll have a square root, and let's use that function again, nth root. We want 4th root. So take a look at that one as well. So it's going to be more flat on the y-axis instead of on the x-axis, and then it will shoot to infinity way slower than the other one over here. So it will eventually go to infinity, but really, really slow in comparison to the other one above it. Okay, so the red one will look like this. It will cross up 1. It'll be more flat this way, and then go to infinity way slower than the previous one. And then let's do the one that's with odd. So if this was odd, and this was 5th root, let's say, same idea here. Let's zoom in on it a little bit. So the purple one is the original cube root, and then the 5th root would be a little bit more flat near the y-axis this way, so more flat vertically, and then it will go to infinity way slower. So let's draw that one. So the red one will be the h, goes through here, goes to infinity slower, through here, like so. So recall what I said a few days back. I talked about critical points. So over here we have tangent line that has a slope that's infinite or undefined. So that point in the middle is a critical point versus over here, because the graphs look very similar here, we have a tangent line. Let me draw it with a different color. The tangent line on this one is tangent line will have slope that is 0, not undefined or infinite. So horizontal slope here in the middle for tangent line, vertical slope here. So that's the difference between the two of those. Any questions so far about these power functions?
Yeah, isn't the line not supposed to hit a tangent? Oh, sorry, not tangent. Oh, never mind. I just realized you said tangent, not asymptote.
Yeah, it's not an asymptote because an asymptote is supposed to approach but never touch, right?
Yeah, that's why I was confused.
The tangent line, tangent line represents that the slope of the line that I draw matches to the slope of the curve at that point. Okay, thank you for clarifying. All right, so then we're going to learn how to do any type of power function. So notice some of these will not be polynomials. Actually, none of these are polynomials, right? Because this is negative exponent. That's a fraction exponent, negative exponent, fraction exponent. This is again a fraction exponent, even though it's written as a root. So none of these are actual polynomials, but on the test you might be asked to sketch a power function, and then I'll show you how to do polynomials in the topic 3. All right. So in order to understand how to do that, I'm going to do these 6 with you, and then for your concept check, you're going to do a couple more yourself. Okay, so here's the strategy. And if you're looking to put something into your cheat sheet, this is the important part to put into your cheat sheet. And what else is important over here? Probably this information here that captures pretty much everything that I had up there as well. You could also over here just add, because if you don't want to put it twice, you could just say here a can be anything. This exponent doesn't have to be only natural numbers. All right, so how do we do this? So first of all, there's 3 bullets, 3 steps to it. First step is to decide on the right side of the graph using the following criteria. You're going to look at this exponent that's written here and ask yourself if it's negative, then it's going to resemble rational function, but just draw the right side of the graph. Don't bother putting the other one on the other side because it all depends on what else is part of the exponent. If the exponent happens to be between 0 and 1, then you know it's going to resemble kind of the square root or cube root type of graph. Again, don't draw anything on the other side, just the right side. Okay, why is that? Because in Desmos, as you saw over here, even if it was cube root, not square root, do you see how this right side is looking kind of the same thing as a square root? I know there's other part to it on the left side, but we're looking at just right of 0, okay? Then if x equals 1, then it just becomes linear, so that's kind of boring. And then the ones that are exponents bigger than 1, then it's going to resemble like a parabola Or on the right side over here, do you see how it goes up anyways, even though it does something else on the left side? But the right side is always going to have this twist that will go more flat near the 0 and then shoot up to the to infinity. Versus with the roots, it's more flat on the y-axis vertically and then shoot to infinity really, really slow. Okay, so that's the first idea. So let's go with our first question. The right side of it is going to be what? We have a negative exponent, so let's call on Christina. Can you unmute yourself, say hello?
Hello.
Hello, Christina. So based on this exponent is -3, which picture do I start drawing? First, second, third, or fourth for the right side of the graph? What do I draw here?
The ones that's the reciprocal.
The reciprocal one. Okay, very good. So you draw this right side first. Then step 2, decide what the left side will look like and think the following. Will there even be a left side? And if there will it be odd symmetry or will it be even symmetry? So the way to figure out whether something is odd symmetry or even symmetry, recall in the last unit, we plugged a negative into the function and we verified if it was equivalent to negative of the original. And for even symmetry, we said that if we plug a negative in, we would get the function that was originally back without any extra negatives. So that's what it was before. So for us, I'm going to do this computation on this side here. I'll stick a negative inside here, and I will put my x to the 3 on the bottom, except with a negative on the inside. The reason why I placed it on the bottom, so it's easier for some of you to just think of it this way. So can you tell me, Christina, and this, by the way, I can put it down like this as well. What would happen to this negative with a power 3? Would that negative stay or disappear?
It'd stay a negative.
It would stay as a negative. So this is going to be equal to a negative of the original function. Would that be even or odd?
Odd.
Odd. So because it is odd symmetry, remember how we talked about with odd symmetry or even symmetry? We said, oops, I just made this smaller. We said that for odd symmetry, this quadrant resembled that one. And this quadrant resembled that one, right? We did that before, so I'll put it under odd. And then we also had, with even, we had these two quadrants were the same compared to these two were the same, like that. Let me put the axes back in here because they're missing. So this was the odd looks like this, even looks like that. So because we just identified this one with Christina that it is odd, we're going to take this graph over here and put it on this side over here. And then we can say that this 2 is just a vertical stretch. So because I don't have a scale, we don't have to worry about the stretch. So step 3 here is to adjust the graph only if there's reflections. We can ignore stretches since we won't put the scale on the graph. So we can't really tell whether there's something stretched or not. Okay, so Christina, let's do another one, okay?
Okay.
Do the next one. All right, let's identify again. There's 3 steps to this. So first step is look at the exponent and tell me if it's falling in this region negative between 0 and 1, 1 or greater than 1.
Greater than
1.5. Greater than 1. So it is this picture over here. So you start first by drawing. Something kind of looks like a parabola, except it might not have the arm going to this side at all, or maybe goes down, we don't know. So that part okay so far, Christina?
Yeah.
Okay, next thing. We're going to actually change this 1.5 into a fraction. So what number divided by what number gives you 1.5? Do you know?
3 over 2, I think.
Yes, correct. 3 over 2. Now, when you change it to a fraction, then I'd like you to also think about what kind of root it is. So it's sometimes beneficial to look at it, whether what kind of root it is. So would you say this is a cube root or a square root? Which one should I be recording? Do you recall? In grade 11, you learned the type of root. You don't remember?
No.
Okay, quick reminder for everyone. When you have an exponent, let's do m over n. Okay, in my class, when I've done that, I call this the flower power, just to help us think about it. So think of this line right here as the ground. And if you were to draw a flower, here we go, there would be definitely roots in the ground, right? So the roots on the ground means this, the denominator over here is actually the type of root of the actual exponent. So I don't know if that helps you remember things. I hope it does. You're looking at this, the 2 is in the denominator, so that's the type of root it is. So it's a square root, not a cube root. And then the 3 is a regular exponent on the x. Are you okay with that, Christina?
Yeah, that makes sense.
All right, so now that we've recorded it this way, we're going to test out by plugging in negative on the inside to see what happens with it. Okay, let's stick a negative under the square root with a cube. Can we put in negative under the root? Is that allowed?
No.
We get an error.
Yeah.
Because we get an error, that means there is no left side to this graph. So you know how we drew the right side here, but then we're not going to draw anything on this side at all, just because there is, it's not part of our domain. We can't stick a negative into this equation. Now the only thing left here is, do you see how there's a negative on the 0.4? I know there's a compression factor here, but this negative, we do have to adjust the graph with the reflection. So this is a version of not reflected, 1.5, but we want to draw a reflected version. So we're not finished. So let me draw the final one over here. It would be reflected in the y-axis. So this negative 0.4 is reflect in y-axis. And so this is the final version for our graph with the reflection. Any questions, Christina?
Wouldn't it be a reflection in the x-axis or no?
So because this is the number is outside of the function, so the function here is the actual root. So this is a negative on the kind of like on our A when we talked about transformations, unit number 1, review topic 1, transformations. Let's look it up over here. So, oops, where was it? Over here. So the A is outside of the function here, and so that reflection is in the x-axis. It's a vertical reflection, so thinking that it's going from up to down. So that's a vertical reflection, but it's reflecting in the x-axis.
Yeah, that's what I said, because you said it's a reflection in the y-axis.
Oh, I meant x. So Christina just got a point. Let me record that. Christina, thank you. I meant one thing. I thought I said it the right way, but I recorded the wrong way. So Christina, mistake point. Thank you. All right, Christina, one more with you or switch to another person?
I can do one more.
One more? Okay, so let's do one more. So this one, we have 0.4 as an exponent. So does it resemble the first one, second one, third one, or fourth on the right side?
It's the root.
Okay,
right?
so this one version. Okay, so we're going to write down. So it will go like this. We're ignoring the negative in front for now. So this is just x to the 0.4 version. Let's continue on changing that 0.4 into a fraction. So what is 0.4 as a fraction, so we can identify what kind of root is this? It's like equivalent to 4 over 10. Just reduce 4 over 10 for me.
2 over 5.
Okay, so 2 over 5. So would this be a fifth root or square root?
Fifth root?
Fifth root. Okay. All right. So now that we've changed it to that form, then we can stick a negative inside to verify what happens with the negative on the inside. So fifth root of negative x squared.
It remained the same.
It will remain the same as before. And because negative on the inside will just be positive, and this is equivalent to our original. So would you say this is even, odd, or neither symmetry?
Even?
Even symmetry. And because it's an even symmetry, it's supposed to look the same way in this quadrant as in that quadrant. So it's going to look like that. It's going to have this sharp point. Okay, so we drew that, but this is not the final yet. The final one, because there's a negative on the coefficient, again, that negative will reflect in the x-axis just like the one I've done before. So it's going to be a sharp point going like this. All right, Christina, thank you. You can mute yourself unless you have questions.
No, I'm okay.
You're good? Okay, let's go on to Mousy. Can you unmute yourself? Say hello.
Hi.
All right, so because I don't want to go back and forth, scroll up and down, I'm just going to place our little notes on the bottom here as we do the question, the next one. So this particular one, look at its exponent. Would it be like the first one, the middle one, or the second one, third, or fourth?
The first one?
First one, correct. So we're going to draw this version first. Then you can change how it looks if you prefer it. So it looks like that. And then we're going to stick a negative inside to see what happens with the negative. So a at negative x will be 5 of negative x with a square. What happens to the negative here? Does it stay, disappear, or give you an error?
It stays. No, it disappears.
It disappears. And because it disappears, it became original a of x function. So would that be even symmetry, odd symmetry, or neither symmetry?
Even.
Even symmetry. And for even symmetry, it means that we will have reflection over here. So this quadrant is going to resemble that quadrant completely. And 5 doesn't have a negative on it, so this would be my final graph. I don't need to do any reflections here. Mousy, are you okay with that part?
Yep.
Okay, let's do another one. X to the 1/4. Which one is it? Oh, I maybe moved it too far down. So 1/4. First, second, third, or fourth?
Second.
It is the second, so I'll draw this version for the right side first. And let's change it to a square root, fourth root, or, well, actually it's fourth root, I guess. Can't have 1th root. There's no such thing. So it's a 4th root. Are you okay with that part, Mousy?
Yeah.
Okay, now we're going to stick negative inside and see what happens. 4th of negative x. Does the negative disappear, stay, or give you an error?
An error.
An error. And so because there is an error, there will be no left side at all. And this 4 in front as a coefficient is positive, so I don't need to reflect anything. Okay with that?
Yeah.
Okay, last one. This particular, where would it fall? First, second, third, or fourth? It might help to rewrite it as an exponent with numbers on top and bottom. What would
second,
be on
second? Oh, what would be at top?
Yeah.
The 7.
Yes, very good. So because it's 7/6, that's definitely bigger than 1. So
it would be the last one.
The last one. Okay, so we're going to draw the last one, the curve this way. All right, so now we're going to think about putting in a negative on the inside, and I like to do it on the root version. So -2, we're going to put inside on the root version the negative. Would this negative stay, disappear, or cause us an error?
An error?
It would give us an error here as well. Okay, so this is not the final one though, because this coefficient 2 has a negative on it, so I need to reflect it. So the final version of this graph is actually this way. Okay.
Okay.